Today I wanted to talk about cholesterol, what it is, why we need it, and when it can cause trouble. This is by no means a comprehensive guide, it's just meant to be a good foundation to help you think about it a little bit more clearly. Let's get into it. So, what is cholesterol? Cholesterol is a lipid. It's a class of molecules which are not very water soluble. Another type of lipid is fat or triglycerides. Cholesterol is made in every cell in our body. It helps make up the membranes of our cells and gives them a little fluidity so they can go into narrow areas and deform. It also supports transporters, which are little channels that allow ions and molecules into and out of our cells. They're also the precursors for several hormones. You see this cluster of carbon rings here is something that cholesterol has in common with steroid hormones. But the cholesterol has this OH group on the left side of the drawing that makes it a sterol, so cholesterol. Cholesterol is also used by the liver to make bile acids, which help us digest our food. So cholesterol serves a lot of important roles in the body. When we do blood work to check our cholesterol, we're actually checking the cholesterol that's being transported in the blood. Now, if I said that every cell produces its own cholesterol, why would we need to transport it in the blood? The reason is because in some situations, the tissues need more cholesterol than it's able to produce. For example, in a state of high stress, the adrenal glands might need more cholesterol than it can produce itself to make the hormone cortisol. The liver is a net exporter of cholesterol, making more than it needs, and this is sent out in the blood. The problem is that lipids are hydrophobic. If you've ever mixed oil and water together, you know that they separate out. So cholesterol just can't float around in the blood by itself. It needs to be transported. So how does the body do this? Well, it puts cholesterol and triglycerides, which are another lipid, into these balls called lipoproteins. The surface of the ball is made out of molecules called phospholipids. The head of the phospholipid is hydrophilic and faces outwards toward the blood. And the tail of the phospholipid is hydrophobic and faces the cholesterol and fat inside. We describe molecules like this as amphipathic. The fact that the outer part is hydrophilic means that it's soluble in the blood, which is largely made out of water, and the inner part is hydrophobic, meaning the cholesterol and fat sit comfortably inside and aren't repelled out. You can think about these like little submarines carrying cargo. There's one more important component of the lipoprotein, which is the apolipoprotein. Now, people get this confused. So the whole thing, the ball with the cholesterol and the triglycerides inside, is the lipoprotein. There are these proteins that sit on top of, and actually in the wall of the lipoprotein, called apolipoproteins. Apolipoproteins are made in the liver, and they're on these lipoproteins, and different apolipoproteins send cholesterol to different places in the body, which becomes important. The apolipoprotein also affects the size and the lipid content of the lipoprotein. Let's talk about the two main types of apolipoproteins, apolipoprotein A or ApoA, and apolipoprotein B or ApoB. You've probably heard of ApoE with respect to Alzheimer's disease. ApoC3 is also important with respect to hyperinsulinemia and insulin resistance. But let's focus today, for the sake of simplicity, just on the main players, which I'll call ApoA and ApoB. ApoA is on HDL and brings cholesterol back to the liver, where it's excreted in the bile, lowering the blood concentration of cholesterol, which is why HDL-C is generally thought of as the, quote, good cholesterol. But for any lipidologists who are unsatisfied with this overly simplistic account of HDL, I will say that it is more complicated than that, and it's more complicated the more you read into it, but we still don't understand everything. And by more complicated, I mean that experimental drugs to increase the HDL-C have largely failed to decrease the risk of cardiovascular disease. So we think that it's probably more likely the function of the HDL that's important here. Moving on to ApoB. There are two types of ApoB. There's ApoB48 and ApoB100. And that just refers to the length of the protein. So ApoB100 is 100% of the length of the protein, and ApoB48 is 48% of the length of the protein. ApoB48 is in chylomicrons, so it's responsible for transporting lipids from the gut that we eat into our lymphatic system, which then takes it to the blood. We're going to be mostly focusing on the ApoB100, which is on the VLDL, LDL, IDL, LP(a), which is an LDL, and these are the atherogenic particles, the ones that actually bring the cholesterol into the wall of the arteries. So what do all of these names mean? VLDL, LDL. The DL stands for density lipoprotein, and the letters before describe how dense they are. And so, for example, the VLDL on one end of the spectrum is the very low density lipoprotein. These guys are big, filled with lipids, and have relatively low protein content compared to, on the other end of the spectrum, the HDLs, which have a relatively low lipid content and more proteins, so they're more dense. So LDL cholesterol is often referred to as the bad cholesterol, but I don't really like that term, and I'll explain why. We started the talk by saying that all of the cells in our body need cholesterol, they produce cholesterol. If they can't get enough, they're given cholesterol by the blood. So what's going on here? Let's compare cholesterol to bricks. Okay, so bricks can be used in a good way. They can be used to build houses. And they can also be used in a bad way, say to throw at people or break property. And so you wouldn't say this is a good brick, this is a bad brick. We would say the person throwing the brick is a bad person. We would say the person using the brick to build a house is a good person. It's the same thing with cholesterol. So instead of calling LDL cholesterol the bad cholesterol, even though higher LDL cholesterol is concerning, we want to think about the ApoB particle, the apolipoprotein B, that protein that sits on the surface, in the surface, I should say, of the LDL, the VLDL, and the IDL particles. So when your doctor checks your cholesterol, the most common test that he sends is the so-called lipid panel. And I have mine up here, we can talk about it. So based on what we were talking about, the total cholesterol number right here is if you took all of the particles in the blood, the VLDL, LDL, IDL, HDL, you busted them open and you put them, on a scale, you got the mass, so the milligrams, in 1 deciliter of blood. And so mine here is 105. We can further subanalyze the different types of cholesterol here. So we have the LDL cholesterol here. We have the HDL cholesterol here. So again, that means for the LDL cholesterol, if we took all of the LDL particles, busted them open, took out the cholesterol, measured them, we would get 38 milligrams per deciliter. Same thing with the HDL cholesterol. And then you see this number here, non-HDL cholesterol. And so that includes the VLDL, LDL, IDL. So if you add up the HDL cholesterol and the non-HDL cholesterol, it should come out to equal the total cholesterol. And finally, there's the triglycerides, which are that other lipid inside the lipoprotein. So this is okay. This tells us a lot of information. But what you don't see on here is the apolipoprotein B, ApoB. And unfortunately, that's not considered a standard test at this time. It's unfortunate because it's been proven that it more closely correlates with cardiovascular risk than the LDL-C. So I think it's probably a matter of time until it is incorporated into the standard lipid panel. But for now, you have to request it from your doctor if you want that sent. Well, that's all for today. I just wanted to give you a brief introduction into cholesterol, why we need it, how it's transported, and how that transportation system affects where the cholesterol goes in the body. And then a little bit into how to interpret your lipids. I hope you liked it. I hope you got some value from it. In another video, I'll go into how the cholesterol is transported into the wall of the artery, how it can form a plaque, and then causes some problems. Thank you for watching.